Let's continue exploring derivatives and power rule, but today a little twist on things. All right, so let's look at what we're talking about today. So some of the equations today we're going to need to simplify before we can actually take the derivative. So for example, we want no negative exponents, we want to combine like terms, and anytime we see radicals, we want to change those radicals into exponent forms, simplify them, and then in the end put them back into radical form. So let's see what all of this means to us. So let's jump right into it. So a nice simple one, let's say f of x equals, let's say, 6x to the fourth. We'll just start this right here. So what's different about it today is that now we've got these rational expressions here, okay? And the x is kind of located on the bottom. Now, we don't want those numbers on the bottom. But remember, we're able to rewrite this into a different form, the way to move that exponent to the top of the fraction. So we could have 6x, but in order to move that exponent now becomes negative. So these are the same things. But instead of having it as a fraction, we have this as now one line of math. All right, so we got f of x here. Now, once we have this, we can go ahead and start taking our derivative. Now remember, it's take this number, multiply it to the front, so f prime, showing me the derivative. So I'll write it out, negative 4 times 6x. All right, and remember, now this one goes down by 1. So it's negative 4 minus 1. So now we've got negative 24. That's negative 4 times 6. All right, x to the negative 5. So negative 4 minus 1, negative 5. So this is the derivative. But we want to put that back. Remember, no negatives, no negatives. So in order to get that back to a positive, that x to the fifth is going to drop back down to the bottom. So this is going to be actually negative 24 over x to the positive 5. So that is the derivative of that original. Okay, we're going to see a bunch more polynomial cases where there's multiple terms, but we're going to be using the same rules there. All right, so f of x equals, we got 5x to the third. See, similar to that last one. Let's introduce a few more terms. 2 over x squared plus 5. And they want us to find f prime of x, or take the derivative. So let's maybe first thing rearrange these. So the first one, we have 5x to the negative third. Remember, we want to move this to the top. We make it negative. Plus 2x to the negative 2. Remember, that moves to the top. 5 is already okay. So now let's go ahead and take the derivative. So f prime of x, that's the derivative. All right, this times this. So we get negative 15x. This drops down 1. So negative 3 minus 1, that actually becomes a negative 4. All right, this times this, minus 4x, that drops down to a negative 3. And then this one here is a constant. And remember, when you take the derivative of a constant, that just comes out to a 0. All right, and I guess the last thing we can do is clean it up. So negative 15 stays on top. This term, we don't want negative exponents, so we'll drop it down to the bottom again. So we got x to the positive 4 minus 4 over x to the positive 3. And we don't need that 0 anymore, so there's the derivative. There's the answer. All right, so I feel like the more and more we look at these, the better we get. It's all about repetition, about practice. It's not hard math, just being able to work these out. So let's say 3x over x minus 4x cubed over, whoopsies, not a 4 there, come on, erase, 5x squared plus 6x. Okay, now we can move stuff to the top, or if you notice this time, stuff can cancel out because we've got x terms on top and bottom. See, like here, 3x over x, those x's cancel. Leaves me with just 3 there. Minus x cubed on top, x squared on bottom. 1x will survive, and it'll be on the top. So this is really just 4/5 x, and then plus 6x here. Okay. So this is still my original equation, just rearranged. It looks like 3 terms, and we could take the derivative now, but I look at these two, x and x, these are like terms. So one of our rules from above, combine like terms. Only problem is one's a fraction, one's not, so let's go ahead and do that. 3 is just 3. I've got an over 5. I want to make this one an over 5, so let's say over 5. That means 6 over something, 30 over 5. So again, we're combining these last two. I made common denominator. So negative 4/5 plus 30/5 should come out to positive 26/5 x. Alright, so again, we've done all this, and this is still just the original. But they want us to find the derivative. So let's go ahead and do that. So f prime of x equals the derivative of 3, that's a constant, that just comes out to 0, plus the derivative of a number in front of an x1 term is just going to be that number, so 26 over 5. So the derivative of all of that after all that work is just 26 over 5. There we go. Alright, let's see if we can get a bit more complicated. So, for example, f of x equals x to the 5th plus 3x cubed minus 2x squared plus 5 all over x squared. Okay? Now, when we've done this previously, we've liked different pieces. Here we've got one big fraction, but on top, I'll circle it for you. 1, 2, 3, 4 different pieces over one x squared term. Now what this means is everything on top is being divided by x squared. So what I could do is split these apart. So x to the 5th over x squared plus 3x cubed over x squared minus 2x squared over x squared plus 5 over x squared, because everything's being divided by x squared. And now we've got 4 distinct terms, and we can simplify, we can deal with the negatives if we have to. So let's see what happens. The first term, because remember this is still just the original equation, x to the 5th over x squared, that comes out to x to the 3rd, nothing on the bottom. This next one, we get a 3x minus, those two cancel, 2 plus, nothing really cancels there, but we know we need to move this to the top. So it's going to be 5x to the negative power, or negative 2 power. And now we're ready to find the derivative. So let's do that. So that comes down, so 3x, and then drops down 1 squared. Plus, okay, remember when it's an x1, all it survives is that number, so plus 3, minus the derivative of a constant is 0, so we don't need to really write anything there. Now for this last one, that moves forward, so negative 10x, this drops down 1, negative 3. So technically that is the answer, but we want to clean it back up because we don't want negative exponents. So we've got 3x squared plus 3 minus 10 over x to the positive 3 now. Remember, that's how we make it positive. Alright, I think one last one for these notes. because there's something we had in the rules up there that we haven't seen yet. It's radicals. So f of x equals square root of x minus 2 cube root of x plus cube root of x squared. Alright, we've got radicals this time. Radicals don't really make too much sense to us, but we know we can change radicals into exponent form. So let's rewrite this. Now for this one, for the first term, if we don't see the numbers, what are they? Inside, the exponent is 1, and if I don't see a number up front, it's a little 2. So remember, to make that exponential form, it's x to the 1/2. Remember that 1 stays there, the 2 travels back. For the next one, we have negative 2. Again, we don't see the inside number. So we've got x, 1 stays there, 3's underneath. Plus, this one already has a number, so this is x, 2 on top, 3rds on bottom. Okay, so that's a little review of our exponential stuff. Now let's go ahead and do our derivative. The only problem this time is we've got fractions. So we've got to remember our adding, subtracting, multiplying fractions. So just imagine it was the exponent, which it is. This number gets multiplied to the front, so 1/2 x, and then it goes down by 1. What that means is 1/2 minus 1. So we'll do the math on that in a second, but let's go ahead and do the rest of this. This number gets multiplied here, so negative 2/3 x to the, drops down 1, 1/3 minus 1, plus, this number moves up here, 2/3 x. This number drops down 1, 2/3 minus 1. Okay, so we've got to do the fraction subtraction. Alright, so we'll just do it piece by piece. 1/2 minus 1, that's a 1/2 minus 2/2, which comes out to negative 1/2. Alright, so that was that one. I'll just color coordinate these so we can do it. 1/3 minus 1 is the same as 1/3 minus 3/3, which comes out to negative 2/3. And then that last one, 2/3 minus 1 is the same thing as 2/3 minus 3/3, which is negative 1/3. Okay, so I'm going to write those back onto that equation there. So f prime of x equals 1/2 x to the negative 1/2. Okay, so I'm putting these numbers onto the x's now. Minus 2/3 x to the negative 2/3 plus 2/3 x to the negative 1/3. Alright, so again, not hard math, just a little bit complicated trying to follow it. But remember, we can't have negative exponents, so that stuff needs to become positive by moving to the bottom of these fractions. So see how I do this. This has got to move to the bottom. I've already got a bottom number, so it's 1/2 x, now it becomes positive 1/2. Minus, that needs to move to the bottom. This is already on the bottom. 2 on top, 3 x to the 2/3, positive. Plus, that needs to move to the bottom. That's already there. So 2/3 x to the 1/3. And this is great. This is awesome. But we don't want it in exponential form. We want it back into radical, how we started. So again, this is the derivative answer. 1/2. I need to rewrite this back into radical form. Anything to the 1/2 power is the same thing as square root. 1/2 is the same as square root. Minus 2/3. I need to rewrite this. It's going to be a radical. X inside keeps the 2 here. Little 3 moves out here. Plus 2/3. I need to rewrite this. Radical x to the 1. Little 3 moves out there. It means cube root. So this right here is your final answer for that derivative.